Thank you everyone for joining us on today's session, introducing GuardDuty Runtime Monitoring for Amazon ECS, including Fargate ECS, which is a big customer ask that we've had. And it's important to understand why we thought we needed to do this and bring threat detection to ECS and including serverless containers. And it's because they all face the same type of threats to their workloads that we see on non-container workloads. Some of the more common ones that we see are things like crypto mining, denial of service activity, using those compromised workloads to try to attack or identify other vulnerable targets, or trying to use those and the permissions that they might have to get access to other data and secrets within your account. And one of the really most important things when it comes to getting security into a workload is making sure that it's seamless and that it can be applied consistently. So before we go too deep in the service, I want to introduce Kunjan from our team, who's going to walk us through a quick demo on showing how easy it is to enable the service across all your accounts in the organization. So getting that persona of the security administrator, but also equally importantly, showing the view from the persona of the builder, the application owner, who doesn't really want to know about how this works. They just want to run their application and do so securely. And so we'll show how seamlessly that can be done. Kunjan.
Thank you, Ryan. Hello, everyone. Thank you for coming. My name is Kunjan. I'm with the GuardDuty team, tech lead on the GuardDuty team. And I'm going to do a quick demo on what the new experience looks like for enabling runtime monitoring on GuardDuty, with GuardDuty on ECS particularly. So just a quick show of hands, people familiar, anyone, like how many have heard of GuardDuty and GuardDuty runtime monitoring particularly? Okay, that's good. So I will just a quick intro to GuardDuty, threat detection service that monitors your accounts and workloads and to detect malicious activity and then give you insights so that you can remediate them. So let's take a look at some of the, Let's take a look at what it would be without runtime monitoring. So I'm looking at a finding in GuardDuty console. So this is a console that typically a security person will be looking at for his accounts. And I could see that I'm getting a Bitcoin mining activity, and it's giving me details about the instance that was impacted, the account, the actual activity happened in, the tags, the profile that was used, and actually also the DNS. This was a DNS request made to a domain. So great insight, something that could help investigate what needs to happen next, but more context would be useful. For example, it would be nice to know if this is an ECS EC2 instance particularly that is running thousands of tasks, then was there one task that did this or were there many? And what should be the remediation? How do I actually get to the root cause quicker? So this was like one of the things that we wanted to solve with runtime monitoring, where we are now giving insights into the actual operating system activity, so we can pinpoint like what actually is responsible for this activity. Is it the process? Is it the file that was downloaded, or is it the network connection? So that's what runtime activity actually gives us the insights into. So as I mentioned, this is an instance in my account that actually belongs to an ECS cluster and did this activity. So how would an attacker actually, or a malicious actor accomplish something like this? So one way is, I can take you to my ECS console now, show you how easy it is for someone to actually just go and create somebody to create a task and then launch it and use it for mining cryptocurrencies. So in this particular example, this is a pretty standard task definition. I'm using a stock Amazon Linux kernel base image, and then I'm using XMRig. XMRig is the open source cross-platform tool for mining cryptocurrencies like Bitcoin, Monero. So all I have to do here is specify the command and pretty much fire off the task. And now this task is actually going to be running either as a Fargate or as on my ECS EC2 instance. And we saw what the finding would look like if it was on EC2. But what about Fargate? So this is what we are actually now bringing. This is the gap we are trying to solve, which is monitoring on Fargate for activities like these, and also to give more insights on ECS EC2. So to do that, I'm going to take you back to my GuardDuty console now and bring you here into runtime monitoring. So what I have here are 2 accounts. So everyone's probably using organizations in their accounts. So me as a security persona, who is a GuardDuty customer in this case, will enable runtime monitoring for my member accounts. So this is the new runtime monitoring interface we are like releasing now, which lets you enable runtime monitoring, and then lets you choose between 2 different EKS and ECS, and gives you the option to let GuardDuty manage it for you, or you can leave those options off and manage those services yourself for managing the GuardDuty agent. So what I'm going to do now is I have a account currently that is my member account. This is one of my, in my organization, this is a member account that is already a part of the org. I'm going to enable runtime monitoring on it. And I'm also going to be enabling, let's see, the EKS and both the ECS management as well, the agent management. What that does is it lets GuardDuty manage the deployment of the security agent as well as the updates to it as well. We do everything that is required to actually deploy the agent, put the necessary VPC endpoints so that the agent communicates back. So I'm going to now go and quickly show that this account is now enabled with EKS runtime monitoring. And then the other options on this page are about you as a dedicated admin, what are your settings? What are the settings for any new accounts that join your organization, as well as any existing active accounts? So you could do that through like various helpful dialogues that we have here. I'm going to switch over to now my ECS console and see if runtime monitoring has been on. So now I'm in my ECS console, and this is a different persona. This is an ECS operator or a different account administrator who is looking at this, and he's the one who is actually running all the ECS tasks. What they see in their console is a runtime monitoring turned on. So that means this account is now monitored for ECS activity like ECS, EC2, and Fargate GuardDuty is enabled for that. Before I go too deep, we will come back to what runtime monitoring does. I'm going to stop here and just fire off a few tasks. One of the crypto trigger tasks that we previously had, for example, I'm going to just launch that as Fargate. And towards the end of the slides, we'll come back and see the findings for this. So I'm just going to quickly launch real quick here. Select launch type Fargate. And I'm going to do that for a couple of the other ones too. Okay, so now we can see that a couple of tasks that have been launched. One of the things that happens when these tasks are launched, okay, this one is not there yet. Let's see. Okay, it's turned on now. Okay, I need to maybe wait for a second here. Okay, turned on. I'm going to try again. If not, I'm going to come back to this. Okay. Why don't, Spiros, you continue with this, and then I'll come back to this. I'm going to switch back to one. Okay, cool.
So, can you hear me okay? A quick refresher for those of you not familiar with ECS. ECS is AWS's native container management service, and it is deployed across a variety of compute options, from managed EC2 instances to serverless compute with Fargate, and also on your own on-prem host with ECS Anywhere. It's a very mature service, been around for many years, and it has scaled to billions of new task launches every week. And the one thing to note here is that 2 out of 3 customers who are new to containers, they choose ECS because it's so much easier to onboard and manage. The majority of them being on serverless using AWS Fargate. And although we've had hundreds of thousands of customers, our biggest customer is Amazon itself. From traditional databases like RDS and new AI/ML services like SageMaker, even GuardDuty runs on ECS, as well as hyperscale consumer services. Amazon.com, Prime Video, Fire TV, they all run workloads on ECS. And that drives the ECS team to build high availability, high resilience, and security, and build up to a scale that needs to serve Amazon workloads. And you, our customers, get the benefit of doing that work.
Thank you, Spiros. So just give a little overview, too, on GuardDuty. So we launched GuardDuty, actually, 6 years ago here at reInvent, so almost 6 years to the day. And when we launched the service, one of the key tenets was we wanted to have a very full function but cloud-native threat detection service that could be used by customers of all sizes and all geographies and all industries. And in fact, we have customers ranging from single developers all the way up to some of the largest enterprises, including Amazon and AWS ourselves. In fact, over 90% of the top 2,000 customers for AWS are also GuardDuty customers. And we are actively protecting over millions of accounts, over 500 million EC2 instances at any given moment, and millions of individual S3 buckets with their S3 data events. In fact, we now process tens of billions of events per minute across all of our global regions, supporting all of these customers. So we're able to provide this protection and do so at a really massive scale. And we've kind of come a long way since we first started in 2017. So when we first launched GuardDuty, we had 3 log sources, so VPC flow logs, DNS logs, and CloudTrail. And that gave us insight into network connectivity, so with flow logs, DNS query requests gave us the information about what domains were being queried. And CloudTrail, very importantly, from a cloud-native standpoint, allowed us to understand how your users were interacting with other AWS services. And as we did so, we started hearing from customers that we needed to increase the breadth and support of the different sources. So in 2021, we launched with S3 data events. And this allowed us to get insight into how customers are accessing objects and buckets within your customer estate. So looking at gets, lists, puts, deletes, events. As we started seeing more and more adoption across our customer base with container services, we added EKS audit logs that give us insight into the control plane for customers using EKS. And then this year, we were quite busy. We added support for Aurora RDS login events, so looking for unusual activity from logins to your RDS Aurora databases. We added support for Lambda flow logs in order to identify supply chains attacks or account compromises that try to leverage Lambda in order to evade detection. And then Runtime Detection, we launched originally for EKS in March, and as now here at reInvent, we are extending to ECS and EC2. When we get all of this data, we do quite a bit in order to identify different and complex threat types. So we add threat intelligence. Threat intelligence is fairly common and simple to get. We have lots of different sources for our threat intel, though. So we do partner with some of the well-known vendors. We also generate a lot of our own threat intelligence. So we operate through our MadPot team, one of the largest honeypot networks, that gives us good insight into active threats that aren't just active, but are actively targeting AWS customers. We have some complex stateful analysis that allows us to look at events as they go through different TTPs on the attack chain in order to identify complex attack types or attacks that are multi-stage and require lots of different events over time in order to identify them. We are heavy users of ML technology, so we use machine learning for our CloudTrail analysis, for EKS audit logs, for S3 data events. All of these models are specifically trained around identifying unusual or anomalous user behavior. We also use ML to help augment our threat intelligence. With our vast visibility of DNS data across all of our global regions, we maintain a very large reputation graph that marks and understands likely benign and likely possibly malicious domains that helps us prevent false positives from our threat intelligence and also helps us identify new and emerging malicious domains, often weeks before they end up on commonly available threat lists. And then lastly, we have malware detection. So we added this last year, where if there's an event that gets triggered from GuardDuty for an EC2 instance, we can automatically snapshot and scan that instance's EBS volumes to identify malware, which helps give the responder context to understand where the malware might be on that instance and what they need to go do from an incident response. All of this accumulates into, we now have 164 finding types, which is 5 times the number of findings that we had when we first launched in 2017. And all of these are consumable by customers either directly in our console, but we also have a number of our partners that support consuming our findings into their platform to help either do things like ticketing or enriching other data that they might have. We also send them out EventBridge so you can have customized actions on your behalf. You can pivot directly from a GuardDuty finding to do a deeper investigation with Amazon Detective, or you can also see them in Security Hub alongside other findings, both from other AWS security services or our big third-party partner program. So when we looked at how we wanted to build and extend all of those existing detections into a runtime platform, we had a couple key tenets that we wanted to follow. And the first one was, when I talked about all of those other log sources, they all come directly from our backend and don't require customers to do any configuration or enablement. And obviously that's not going to be possible if I have to run an agent or a sidecar within your environment. But we really wanted to get this experience to be as close to one click as our customers were already accustomed to. So we wanted to build this in a fully managed fashion that took a lot of the typical challenges and drawbacks with agent workloads away, things like agent management, updates, and deployments. We also wanted to use those agents in order to get the unique visibility that they have from kernel space in order to allow us to detect entire attack chains. Whereas with flow logs and DNS query logs, we can see the outcome of an attack, generally speaking, because now we see that there's going to be some network connection or some query that's being made. But by moving all the way within the runtime, we're able to see a lot of events that can help us identify much earlier in the attack chain, as well as other steps along the way before we get to the point where outbound network connections are being made. And this gives our customers the opportunity to detect those threats earlier, respond to them, ideally before they cause any major damage. And then lastly, we all need to make sure that we're well integrated with our other services, such as AWS Organizations and ECS and Fargate, such that you have the visibility to understand what coverage you have, where you have it, and to make it as easy for the application builder to get that security, and also easy for the security administrator to consume the findings that we are generating centrally without having to do a lot of heavy lifting on their part. So if we look at how this all played out before we had runtime monitoring, when you looked at just the core log sources where we had flow logs and DNS query logs and CloudTrail, we had, even for our container workloads, as Quintin was showing earlier, we can see instance level. We can tell you this instance made a DNS request, or this instance made a connection that we saw through flow logs. And we could do that for container workloads as well as for EC2. We didn't have any support for Fargate before. If there was a finding generator, we could trigger malware scans across those platforms. And we could obviously see the control plane like we had with CloudTrail. But what was really missing, especially for our container customers, that made it very hard for them to action on those GuardDuty findings was the container level context. So it's don't just tell me which instance generated this. If there's lots of tasks or pods in the case of EKS running on a particular host, you need to have visibility into which task is the one that was implicated here in order to properly respond to it. There's also a number of very container-specific threats, so things like container escape activity and other things that aren't really relevant to general EC2 computing, but are very important in protecting and securing a container environment. And then lastly, we wanted to understand process-level events, which again, from looking at log data outside of the instance, we really couldn't get access to. So understanding not just what processes are running, how they got there, and what kind of activities those processes are making, both on the file system, at the network level, or spawning of additional processes, is all important to have a complete solution. So in March of this year, we launched with an integration for a managed add-on for EKS customers that brought all of those additional container-specific detections and container-specific protections to those customers. And then on Sunday here, just before reInvent, we announced and went general availability for bringing those to our ECS customers, as well for the first time Fargate, so allowing you to have that seamless threat detection across your Fargate tasks. And then we're also launched in preview for general compute. So general purpose EC2 compute can also now use these runtime agents to get that extra level of visibility and context. Obviously not relevant from a container perspective, but as we'll walk through some of the detections, you'll be able to understand why it could also add a lot of value for general compute as well. So just to kind of walk through a good example of what a finding looks like before and after and why that context is so helpful. If I think about an ECS host where I connect to a CNC, so a command and control host. For an EC2 instance, we understand we can give you the instance ID, we can give you the tags, the ENIs, a lot of other metadata, but we don't know exactly what on that box was communicating with that command and control server. With the runtime agent visibility, we can tell you the process ID, the exact process ID, its path, its SHA-256 hash that can be useful for doing things like threat intelligence matches, which container that binary was running in, which container image it actually came from. So this can be very useful for detecting things like supply chain attacks. The task name, the cluster name, and the namespace for that application within ECS. So now you go from a single instance that has numerous numbers of tasks on it, where we can pinpoint the exact task on that instance. Now your incident responder knows, I need to go and look at this container image and understand if it's somehow got some malware in it or if it's vulnerable to attack. You know exactly which task within your ECS deployments that you need to go and respond to as well. And this also allows you to operate and to make these detections a lot quicker. So instead of only waiting for the network connection, there could have been other findings about the activity within this host that we could have detected even sooner. So as part of the runtime launch, we are adding 31 new finding types that are specific to the runtime detection, and we'll continue, obviously, to increase that and release further ones down the road. So just some examples of these in the different categories. So we're looking for things that are indicative of malware infection. So connecting to command and control, looking up domains that we think have a bad reputation. And again, that's based on that machine learning algorithm that we run that's looking and building a reputational graph database of domains, both benign and malicious. Things for crypto mining. So again, not just the network connection, which we can also see in flow logs, but in this case, we're looking at it from the runtime space so we get all the additional context. but also just the fact that a crypto miner was executed. So even if the network connection was never made, the simple act of executing a crypto miner, we can detect and match on that and give you a finding for that. Some findings that are very specific, again, to the container environment, which is looking for drift. So general good practice for container workloads is you make your changes in your CI/CD pipeline, and when you need to deploy them, you push a new revision of the container. So it should be unusual for new binaries to show up on a running container and then start being executed. Because we're collecting a lot of the context around what's running in a container, what files are being written, and when they're being executed, we're able to detect, hey, this container's been running for quite a while, and all of a sudden this binary just got dropped on it and started running, which could be unusual and should be unusual for most container workloads. We also have some very specific detections that are for identifying container escapes. So things like mounting a host directory or using a run-C vulnerability. Remote code execution, so things looking for like reverse shells, which could be an indication that someone has found a vulnerability and they're using that to execute a reverse shell and get an actual shell on the box remotely. And then defense evasion. So these are a couple techniques that we start to see malware use. So the first one is fileless execution. This is something that malware writers will do where they'll take the actual malware code and they'll write it directly to memory and then mark it as executable. So it allows the malware to run without ever writing a single file to disk. So it can be very hard to detect, and it really, from looking at kernel events, is really the only way to detect those. So kind of lastly, before I hand it over to Spiros, I just want to talk a little bit more about how we went about building this. So, like I said earlier, one of the key tenets we had is we wanted to make sure that this was as low friction for agent deployment and management. Because when I talk to a lot of customers and you say the word agent, a lot of times you get pushback. And usually there's two major concerns, which is agent management, agent deployment, upgrades, keeping it consistent. And so through our integration with AWS organizations and directly with the ECS and the Fargate teams, we removed all of that heavy lifting, and we managed that completely for you. The second kind of concern is usually around resource utilization. And that becomes really important, especially in a container workload where one of the core concepts and benefits of containers is it allows you to pack more and more of your applications on a single host. So if your security tools start using more and more of that available space, you're not getting the level of efficiency that you're trying to get from moving to containers in the first place. So we built our agent from the ground up ourselves internally, and it's based on the extended Berkeley packet filters, or eBPF, which is very common for a lot of container security tools these days. But we did it a little different in that the agent itself is really a collector of telemetry. So the telemetry that we're retrieving from that agent is then streamed to our backend. So this moves a lot of the computationally expensive tasks of rule matching and doing the analysis on those events off your box and onto our infrastructure. This also allows us to do more complicated and complex analysis on events over time. So it's not always that a single event is enough in order for us to have a detection. We might need to see a series of events that take place over a period of time in order to have the confidence that it's an actual attack. So this allows us to reduce the amount of infrastructure that we require to run the agent, because all of that heavy lifting is done on our side. It also means you don't have to keep the detection library up to date or the rule set up to date, right? Because all of those rules happen on our back end. And that means as our team goes and develops new and additional detections, they're automatically available to all customers immediately, and there's no updates or anything that you have to do that. So the way we get these events is they come over a VPC endpoint, and then we apply our threat intelligence. We do our stateful rules. These are rules where we're looking at, does this event change the previously known state of a container, or is this a detection where we need to see multiple events over a period of time in order to have confidence in a detection? We start to apply some of our machine learning algorithms to look for anomalies. And then we have a whole set of stateless rules as well that can automatically trigger a finding just on a single event. And then lastly, again, we need to make sure that you know what it is covered, which of your instances, which of your container workloads are covered and protected. So from the administrator viewpoint, they have complete visibility across the entire organization that shows you exactly which instances or which Fargate tasks are covered and in which accounts, and they have the ability to control that centrally as well. So to go a little bit more on the ECS side of this, I will hand it back over to Spiros.
Thanks, Ryan.
Thanks.
So let's take a closer look at how all of this works.
Okay.
And at the center piece of this is the implementation of a lightweight GuardDuty runtime monitoring agent, which we deploy on either managed EC2 or on Fargate. And the way that works, when you launch ECS on EC2, you can use the systems manager, AWS systems manager, to onboard it onto the instance. So that runs as a systemd process in the instance that can monitor underlying resources as well as all your containers in all your tasks running in that instance. Another way to do it is install it as an RPM package from S3 that also goes into the instance and monitors the underlying resources and all your application containers. The other thing you would do on EC2 is also set up a VPC endpoint to get all the collected telemetry from the ECS side over to the GuardDuty service, where you actually calculate and generate security findings. And those security findings you can see on the GuardDuty console, like Kunjan showed us. You can also send them downstream, as Ryan mentioned, to AWS Security Hub or Amazon Detective, or set up an event bridge to send it to a third-party security partner. Looking on Fargate, it's even simpler. In this case, we maintain the GuardDuty runtime monitoring agent on ECR on a private repo. So the one thing you would need to do is ensure your task can allow Fargate to pull that image from that repo. And that's all you have to do. No adjustments to task definitions. We'll manage the image for you. We'll patch it, upgrade it. And every time that you launch a new task, either as a standalone or part of a service, we pull the latest image from ECR and run it inside your task. And in this case, GuardDuty will automatically set up the VPC endpoint. You don't even have to do that. And then all the telemetry data can flow into the GuardDuty service to be able to generate the findings that you can send downstream or, again, view in the GuardDuty console. So with that, maybe we can go now back to the demo.
So the thing we want to show here is, as we saw in the very beginning, Kunjan created some tasks. And what you notice he didn't do was ask for security. He didn't ask for anything, right? Because the administrator had turned it on, we automatically injected the GuardDuty running agent into those tasks. So now those kind of same activities that we did previously, where we saw findings about the instance that showed you which instance was impacted. In this case, we're going to get a lot more context around these detections. So from the EC2 information, ECS information, so the cluster identifier, the task ID that was impacted. But most importantly, too, which container was involved. So if you have a task that has lots of containers in it, knowing exactly which one of those containers was involved in this connectivity problem is important. All of the tags, and then also the process level information. Again, very useful when you're trying to go and identify where on this box is my problem. So instead of just telling you that the instance was crypto mining, we can give you the exact the path to the miner. In this case, it was /xmrig. The SHA, if you want to check that hash against known virus or malware databases. Its process ID, and then also its lineage. So how did this get here, right? So we can go and also check these on all of these, where we can say, how did this process come to be? And this can be very useful, again, in trying to figure out how this started. So, from that previous example on the slides I was showing, if your web server is suddenly calling curl and downloading something, that should be very suspicious. The other one that we had started here was for the reverse shell. So again, you get all of the additional context that was very important for tracking down and understanding how this happened from a process level information. So you can see the name of the binary itself, which is very conveniently named reverse shell, which should make it pretty easy to find. But again, we can see the lineage for how this got started. So what was the parent process of the process that caused this, which in this case it was bash, right? So he ran it from a bash shell. But it again allows you to understand how the offending process came to be, where it's at, what its hash is, what its PID was, and the PIDs of all the parents as well. The other one that I mentioned on the presentation is fileless execution. Again, it's starting to be used by more and more malware. It allows them to infect a running system. It only leaves traces in memory. There's no files on disks. So if you're just doing a regular anti-malware scan for a volume, you won't detect these because the entire payload is contained in memory. In this case, again, you can see the executable path, which is how this is displayed for fileless execution. And then again, what it was that called this. In this case, he ran it from a bash script, so it's pretty simple, but it would allow you to understand how that came to be. But as you can see, you have now a lot more context instead of just the tags and the instance level information. We now know exactly what container did this. We know what task it was launched from. We know what cluster it came from in ECS. And this will allow you to respond to those attacks a lot quicker and with a lot more precision as well. I'll hand it back over to you there.
Thanks, Ryan. So some of the feedback we got from our customers who tried out the feature. Class Method is one of our APN partners as a cloud service provider who uses Fargate. And they really liked the fact that they didn't have to change or update or maintain the image. It was automatically done for them. Another one is Wiz, who's a longtime GuardDuty partner. They operate a security cloud platform. It was really easy for them to integrate the findings from ECS into their platform, so now they can also process those along with all the other compute options. And Flywire, they're a payment process company in the financial industry, and they really see this as a very important feature so they can improve their brand and also the trustworthiness for their own customers, because this is something that's very important in the industry. And as a summary, the key takeaway to take from all this is with the introduction of GuardDuty on ECS and Fargate, as well as the public preview of GuardDuty on EC2, now you have the option of deploying GuardDuty across any AWS compute that you choose. And to take advantage of that, you can also leverage the 30-day free trial for the feature. A few other pointers if you want to learn more. We have a demo at the Modern Apps booth. That's booth 1390 of the expo floor. We're going to be there tomorrow from 3 o'clock. There's also SEC239 that you can learn more about the detection and response capability. And then we're going to do another session on Thursday detailing more of the security functions that you can have with ECS and Fargate. And although today we showed primarily what the security administrator point of view would be, in that section, we're going to talk about what the ECS operator experience is going to be. So with that, I'd like to thank you for coming. Please complete the session survey if you can. And we have moments to take some questions if you'd like.